try drawing the resonance structure that's suggested by this electron pushing arrow. In this series of videos, I'm going to be posing a lot of problems and questions for you. And what I'm hoping is that after every question or problem that I pose, I hope that you're going to pause the video and try to work that problem out on paper. You're going to learn lots more from this video if you try all the questions on your own while the video is paused before you start the video up again and watch the explanation. So I hope that you've given this a shot. Well, remember that we're going to use the redraw and modify technique. So I'm going to start by just redrawing this picture. You can see that I've just redrawn the original picture exactly. Now I have to start modifying it so that it correctly reflects the changes that we're making to make this new resonance structure. Well, where are the electrons coming from? The tail is on this lone pair, so the electrons are coming from this lone pair. So I'm going to erase that lone pair, and at the same time, I'm going to put a positive charge on this nitrogen. So this is the habit that you should be in. As soon as you erase the electrons that are moving away from the tail, you should immediately put in the charge. Remember, the charges are not supposed to be an afterthought. The charges are the whole reason we're drawing this structure in the first place. So put the charges in as soon as you can. So I put this charge in even before I've worked with the head of the arrow. So now let's work with the head. We erased this lone pair. Where are those electrons going? Well, we know that because the head is in the middle of the sigma bond, we're supposed to create a pi bond. We can see that this carbon here now has gained new electrons from the pi bond, so it's become less positive. So I erased that charge. And now I can erase the arrow because I've completely dealt with where the electrons were coming from and where the electrons were going to. So this is the resonance structure that is suggested by that electron pushing arrow. What role did this double bond over here play? Well, the double bond didn't play any role. The only place that the changes are happening is where the electron pushing arrows are. This is a very important point. The electron pushing arrows show you all the changes that are happening. Anywhere where there is no electron pushing arrow, there can be no change. Now, it's true that there's some other resonance forms that we could draw that do involve this double bond, but we're not going to talk about that right now. Right now, we just want to ask what resonance structure was suggested from this one electron pushing arrow. Well, since there were no arrows over here, we haven't made any changes to this part of the molecule. So remember that when you're using the redraw and modify technique, you only make the modifications that are required by the electron pushing arrows. Any place where there is no electron pushing arrow, you should not make any modification to your picture. Notice that I'm talking kind of loosely here. I'm talking about making changes in the molecules and moving the electrons. Remember again that this is all kind of just imaginary or pretend. Remember that in reality, the electrons are not actually moving from one place to another. Remember that actually there's only one picture of what the molecule actually looks like, and that the resonance structures are just supposed to be blended or averaged into that overall picture. But nevertheless, when we're trying to draw the resonance structures, it's much clearer to actually pretend that we really are changing the molecule, and to pretend that we really are moving electrons from one place to another. So from now on, I'm going to be pretending that I'm moving electrons from one place to another without really worrying about it. But remember that that's just kind of a figure of speech. Even though we think of these as electron moving or electron pushing arrows, that's just a figure of speech. That's just a way of bookkeeping to make sure that we're putting the electrons in the right place. In reality, the electrons are not really moving around as we go from one resonance structure to another, because in reality, the molecule is not flipping back and forth between different resonance structures. In reality, the different resonance structures are just blended into a single correct picture of the molecule. So we've seen a couple examples now of what I called the redraw and modify technique, where you start by redrawing the original picture and then you make some modifications. I strongly encourage you to use this redraw and modify technique for all the rest of the examples that we're going to be doing throughout this whole series of videos. When you use the redraw and modify technique, it prevents people from making a lot of mistakes that they otherwise would make. It makes sure that you're only making the changes that are dictated by the electron pushing arrows. This is a very useful technique then when you're drawing resonance structures. The alternative to this, is to just try to draw the resonance structure from scratch. What most people do is they just look at the electron pushing arrow and they try to, from scratch, draw what the new resonance structure looks like. But if you're having difficulty with this material, students that find this material difficult very often make mistakes when they try to draw the resonance structure from scratch. It's much better to redraw the original picture and then modify it. Now, eventually, you may get to a point where you don't find this material difficult anymore, and then you can draw the pictures from scratch. But again, I'm assuming that most of the people watching these videos are people who right now find this material difficult. As long as this material is difficult for you, do not try to draw the resonance structures from scratch. Instead, always redraw the original picture and then make modifications until you've gotten to the new picture. That's what I'm going to be demonstrating in these videos. Okay, here's another picture with an electron pushing arrow, so please pause the video and try to draw the resonance structure that's suggested by this arrow. Let's redraw the original picture. For every arrow, you need to ask yourself two questions. Where are the electrons coming from? Where are the electrons going to? Where are the electrons coming from? Where are the electrons going to? Where are the electrons coming from? From this lone pair. So I erase the lone pair, and I can immediately put a positive charge on the oxygen because it lost the lone pair. Where are the electrons going to? They're going to the pi bond. So I draw the pi bond, and I immediately make this carbon less positive because it gained the electrons in the pi bond. Now I can erase the arrow because I've accomplished the modifications that were suggested by the arrow. And this is the correct resonance structure suggested by that arrow. Remember that one thing we should definitely not do is move this lone pair into a lone pair on this carbon. First of all, we don't do that because the head isn't on the carbon, it's on the sigma bond. But also we know that you never take a lone pair and make it into a lone pair someplace else. That's never done. Instead, we're taking a lone pair and making it into a pi bond. Something else that I can mention is that in the examples that I was presenting at the very beginning of these videos, I was drawing all of the lone pairs on every atom. But actually, in organic chemistry, usually we don't draw all the lone pairs. We usually don't draw all the lone pairs. So I'm not drawing all the lone pairs anymore. After all, this oxygen really has two lone pairs, right? This really has two lone pairs, but I've only drawn one. Now I had to draw this lone pair because this is the lone pair that's being moved. So even though we're not going to be drawing all the lone pairs anymore, you still have to draw in the lone pair that's being moved. Now this oxygen still has one lone pair, but we're not drawing that because there's no need in this picture. So again, at this point we're not going to be drawing lone pairs anymore unless they're at the tail of an arrow and they're being moved.